Okay, so in 8.3, we're gonna graph general rational functions, okay? If you notice, this function has an x squared at the bottom, but nothing up top, no x up top. If you notice, this function has an x squared on the bottom and top. And if you notice here, the top has a higher power than the bottom.
Yeah.
So we have rules for these, okay? If m is less than n, okay? If what is on top is less than what is on bottom, meaning the power that goes with the x. If what's on top is less than the bottom, so meaning, this doesn't have an x and this does, okay? Or this would have a x and this has an x squared, whatever. If the power on top is less than the power on bottom, the line y equals 0 is the horizontal asymptote.
So what would be the format?
What do you mean?
Like you have m is less than n, and you said the what's on the top is greater than the bottom. So
Yes.
would like the format be like m x?
No.
Okay.
Listen, you're looking strictly for x's at this point,
Okay.
okay? If the x up here, okay, if there's an x or if there isn't an x, okay? If the power up here, let's say this said 6x, okay, just for fun right now. This x and this x, which power is bigger?
Well, say
No, which power?
Oh, yeah.
X
yes,
squared.
X squared.
X squared. That's when I use that rule. If the power on top is smaller than the power on bottom, I use that rule. Also, if that just says 6, is the power on bottom bigger than the power on top? Yes, because there isn't one on top. So anytime the power on top is less than the power on bottom, y equals 0 is your horizontal asymptote, period. No questions, you don't have to do any math.
What did you say?
Right.
If the power on top is less than the power on bottom, y equals 0 is your horizontal asymptote. There's no math involved, period. You have to be able to look at equations and tell me things from them.
So if it looks like the thing that's on
So-
the left, it's like-
You know how you see it?
So if,
We're gonna get to
so
that.
if the power, so you're saying if the power is,
Guys, m and n are always powers. That's what they always use in this book for powers. They always say a to the m power times a to the n power. Remember how we did that?
Yeah.
so
And then
if
you
the,
get a to the m n.
so
Oh, I
if,
remember that now.
if the power on the
Yeah, I
bottom is
just read
bigger,
bottom.
it's always gonna be y equals 0.
Yes, if the power on the bottom is larger than the power on top, it's always y equals 0 as your asymptote, no math.
Okay.
Okay? If they are equal, like this is a squared, this is a squared. If they are equal, okay, then you do what we did last night's homework. You take the leading coefficient, okay, a to the m over a to the n. So you take the leading coefficients and you figure out what it is. Just like we did last night. Or Friday, whatever it was.
That was right.
Okay? So that's why on your homework on Friday, everything was for the y equals, for the horizontal asymptote was whatever over whatever, because they all just had x's, okay? When the powers are equal, you take the leading coefficients over top of each other, okay? When the power up top is greater than the power on bottom, here, x squared, this is just x, okay? The graph has no horizontal asymptote.
So what?
Okay.
We're gonna show you because we're gonna graph them.
So if the power
see
on
what-
top
Wouldn't
is,
that-
power,
I see what
is higher than
happened.
the power on the bottom.
Wouldn't that just be the
No.
same thing as the first?
No,
No.
the first one, your horizontal asymptote is this.
It's one.
Wait, so you wouldn't write anything then?
You wouldn't write anything, it
So-
doesn't have
so
any,
it
it's
would
gonna
just-
cross over all.
Yeah.
So
There we
everything's
go.
just gonna be
You would
straight
just
up
tell
and
me, no asymptote, no horizontal
down? Oh,
asymptote.
so it's like one of the things that says like no solution?
Are we gonna have to memorize this?
Yes,
Probably, yeah, I was in.
no, you wouldn't say no solution, Drew, you would say no horizontal asymptote,
But
there's
it's-
still a
but it-
solution,
Oh,
because you're still gonna be able to graph it. We're going to graph one of each, I will show you. Okay?
'Cause-
Okay, let's graph this first one. Okay, and on all of these, you're gonna tell me the domain and range also, because we're gonna work with it. First of all, on this first one, what's my horizontal asymptote?
Y equals 0.
Y equals 0, so I'm gonna go like this. And I'm gonna say horizontal asymptote, y equals 0. Okay? Now, how do I find my vertical asymptote? What do you do?
Well, you would do x squared plus 1 equals 0.
Yes. Okay, I would take this x squared plus 1 and I would say equals 0. Here's my problem. What happens when I do that?
You have to
You get x squared equals,
negative 1.
and can I take the square root of a negative number?
No.
Well, if I did, I get what type of numbers?
No, that's not that.
Starts with an I.
I know what. Imaginary.
Yeah.
Oh, yeah, I know that.
Imaginary. Okay, so anytime you see something in the bottom that's like this, okay, we have to talk about what your domain looks like this, okay? The numerator has no zeros, so there is no x-intercept. The denominator has no real zeros, because they would be imaginary, okay? So there is no vertical asymptote. There is no vertical asymptote. Okay? Because when we graph this, you're gonna see it's gonna look like a bell. Okay? Like it's gonna look like a mountain, and it's gonna fall. Okay? So that means all we have to do is plug numbers in now. Let's plug in,
1, 2, 3, 4, 5.
let's plug in -2,
-1.
-1, 0, 1, and 2. Okay? So my domain would be what in this case? Do we know yet? Do you know your domain yet?
Would it be none?
Well, if there's no vertical asymptote, what's my domain then?
0.
No,
No.
All of them?
all real numbers.
Oh,
I
yeah.
can plug anything in,
Oh, yeah.
Yeah,
I can plug any x in and get a y out. What's my range though? We only know one part of my range right now, and it comes from your what?
Horizontal.
So y cannot be what?
0.
Okay, but we're gonna graph it first before we decide what the rest of our range is, because I'll tell you there's a trick to this one. When we graph it, I'll show you. So let's plug in points. We're gonna plug in -2, -1, 0, 1, and 2, yes?
Yeah.
Okay. Here we go. If I plug -2 in, what's -2 squared?
-4.
-4, what's, no, not -4, what's -2 squared?
Oh, 4.
4. 4 plus 1 is,
5.
so 6 divided by 5 is 1.2. Plug in -1, what's -1 squared?
1.
1, what's 1 plus 1?
2.
6 divided by 2.
3.
Plug in 0, what's 6 divided by 1?
6.
Plug in 1, 1 squared is 1, 1 plus 1 is
2.
2, 6 divided by 2 is, Do you see a pattern?
Oh, so it's gonna be.
so what's this gonna be?
1.2.
1.2.
See, that's what I thought it would be negative.
So
Because-
-2, 1.2. 2, or -1, 3.
Oh, so it's like a U almost, right?
Yeah, it's gonna be like a curve, okay, I'll show you. And then 1, 3, and then this goes here. So it goes like this. Remember, it can't cross this asymptote, but it's gonna curve like this. See what I mean?
This one not okay.
That's what they call a bell curve.
So is that what it's gonna be like every time?
No, that's what it's gonna be like when
No, I mean like when the bottom power.
is greater than the top. That's what it's gonna be like when this bottom power is a squared and is greater than,
Oh.
okay? When it's a squared and there's nothing up here,
Oh.
okay? Now, look, my range has now changed. Because it can't go past 0 and it also doesn't go past what?
6.
6.
Yeah.
So 0 is less than y is less than
6.
or equal to, I guess, because it touches, right? So that is how I create my range. So you need a graph on this before you create your range. Our domain we could just state because we knew we could plug any number in, okay? So we have vertical and horizontal asymptotes, range, domain, and we've graphed it.
Oh, boy.
let's talk about this one.
Whoa.
What do you notice about those powers?
Oh.
They have the same power.
They have the same power, which means what? That the horizontal asymptote,
is y equals a and or
that y equals
2
2 over,
x
no, what's the leading coefficient?
a 1.
A 1. So your y equals, your your horizontal asymptote is y equals 2. Now, how do I find my vertical asymptote? What do you do?
X squared
Uh-huh.
minus 9 equals 0, and then you.
So x squared minus 9 equals 0, so x squared equals 9, and then
you
what?
take the square root.
And what happens when you take the square root of 9?
You get
X
3.
equals 3.
I'm sorry, you get what?
Oh, you get
Wait, no.
plus or minus
Aha,
3.
you get plus or minus 3. So you have two vertical asymptotes. You have a positive 3 asymptote. You have a negative 3 asymptote. Now,
Why is it
Oh,
plus
no.
or minus 3 then?
because you took the square root of 9, anytime you take an even power, or even
get
root,
two.
you get
You
two
get two.
answers. A positive and a negative, because negative 3 squared is
9 as well.
9,
Oh.
and 3 squared is also.
9.
Now look, how many sectors do I have?
A lot.
Okay, so here's how you'll know what your graph's gonna do, okay? You're either gonna graph here and here, and down here, or you're gonna graph here and here, and up there.
Because
Okay,
I'm trying-
But listen, doesn't change. I have to plug numbers in from this section, and from this section. It just is math. There's no way around it. You just have to plug numbers in. Okay, so we have our horizontal asymptote, we have our vertical asymptotes. Now we're gonna plug in numbers. I'm gonna plug in, negative, what is this, 4, 5, 6. So negative 6, negative 5, and negative 4. That means okay, for this section. So let's plug those in for this section, and then we'll figure out what to do next. If I plug a negative 6 in, up here, okay, we're gonna just plug in. I'm gonna erase the numbers out of this middle part every time we do it.
Oh, my
Okay,
goodness.
what's negative 6 squared?
36.
What's 36 times 2?
72.
So you get 72, yes?
Mhm.
Over, what's negative 6 squared?
36.
Minus 9,
25.
27?
Oh, it is? Oh, wait. Oh, yeah, I'll just.
What's 72 divided by 27? It is 2 2/3. 2 2/3.
So we just make that a decimal?
Yeah, 2.6 repeated, that's fine. Okay, now we plug in negative 5, yes? What's negative 5 squared?
25.
25 times 2,
50.
negative 5 squared is 25, 25 minus 9,
16.
50 divided by 16, 3.12. 3.1. Okay, plug in negative 4. 4. Negative 4 squared. What's negative 4?
16.
16 times 2.
2.
So 16 minus 9 should be
7.
7. Good. And 32 divided by 7 should be 4.6. So I'm gonna graph this.
Wait, so then you only take 3 points for that
Nope,
one?
for this
Oh, okay.
section.
That's
Then we're gonna do this section, then we're gonna do this section.
A lot.
Okay? So here, I'm gonna plug in, negative 6, this is 4, 5, 6, and I have 2.6. So, right about here.
Wow.
Negative 5, 3.1. 4, 4.6. 1, 2, 3,
Please
4.
only give us one of these.
So look, it's gonna look like this, yes?
Yeah.
Okay, now, if I go over here, this is 4, 5, 6. What do you think 4, 5, 6 is gonna look like?
Same.
Same thing, so let's do it. Okay, it will be exactly the same, which is not a problem. So you're gonna get, at 4, 4.6. 1, 2, 3, 4.6. 5 is 3.1 and 2.6. So you're gonna get the same type of graph, yes?
Yes.
Okay, now, this middle section is going to be a parabola. Okay? A parabola. And it has to graph here, because these two graphed here, this one's gonna graph down in this section. So we're gonna plug in -1, 0, 1, easy numbers, okay? -1, 0, 1. But do you see how I saved you a little time, because at least you only have to plug this in and it reflects over there?
Yeah.
Okay, -1, 0, 1. If I plug in -1, what happens when I plug in -1?
You get 1.
You get 1, you get 2, right?
Yes.
And you get 1 minus 9, which is -8, right? So 2 over -8 is -1/4. So -1, -1/4. Which means if I plug in 1, I'm also going to get what? -1/4. That's why I chose those. Now, plug in 0.
Well, then you get 0.
You're gonna get what?
0.
Yeah, because anything times 0 is 0, so I get 0. So look, parabola.
So with that, you're gonna have essentially 3,
You will have 3 graphs,
okay.
period. You will. Okay? So anytime
So if
the powers are
power is the same.
equal, and they're higher than just an x like last night,
Right.
anytime they're higher than just an x like last night, okay? Yes, you're gonna have
So then
3
you,
graphs.
so then, okay, and so what if our asymptotes are like a little bit off, or like, I don't,
Your asymptotes have to be right.
okay.
That's the only thing that has to be perfect for it, so.
So that asymptote, then that's not gonna look right.
Correct.
Okay.
Okay. Now, last one. Look here. If x up here is greater than x down here, what does that mean?
No, or not so.
Beautiful, we like those, yes?
I guess.
Because I don't have to do anything. Now, how would I find the vertical asymptote? How would you find the vertical asymptote? How do I usually find a vertical asymptote?
Would you take
X minus,
x minus 2?
No, that's for,
you said vertical?
oh, I did say vertical, you're right, yes, I would take x minus 2. So I say, my vertical asymptote would be what then? X equals
2.
2, thank you. I was being crazy for a minute, thank you for correcting me. Okay, so I only have an asymptote like that, look at that. So I'm gonna have a graph here, I'm gonna have a graph here. Now, these ones are gonna look funky, because they're gonna look something, if I only have a vertical asymptote, they're gonna kinda look something like this,
So, okay.
okay? So we have to like, sometimes plug in a few more numbers to get that picture, that visual, okay? So I'm gonna plug in, let's just count by, can we just count by 2s? Let me do that. Let's count by 2s, okay, because these are gonna be large numbers, I can already tell you. So let's make this a 2 and this a -2. Okay, now let's plug in -8 all the way through +12. So like -8, we're gonna plug in -4, 0. We're gonna plug in, 4, 8, and 12 on the other side. Because I can't plug in 1, or I mean 2. Okay, so let's plug these numbers in and see what we get. If I plug in a -8, okay, then I would have -8 squared plus 3 times -8 minus 4 over -8 plus 2. Yes, I know, lots of math. What's -8 squared?
64.
And what's 8 times 3? So you have 64 minus 24, right?
Yes.
Minus 4, so up top you get 36. On bottom you get -6. What's 36 divided by -6?
-6.
Okay, now let's plug in -4.
Also take all 3.
I know, I'm sorry. I know that these take a while. Okay, -4 squared is 16, right? 16 minus 12 minus 4. What
Yeah.
happens there? You get what?
0.
If there's a 0 on top, then it's automatically.
0.
Okay, plug in a 0. 0, 0, and 0. So 0 plus 0 minus 4, right? Over 2. So you get
-2.
-2. Okay? So I'm going to graph this. 2, 4, 6, 8, -8, -6. 2, 4, 6. Right there. -4, 0, and 0, -2. Look. You can't cross that line, right? And so it's going like this. It looks
So
funky.
you have to make it like a weird parabola?
Yeah, it's a weird parabola, they're weird, okay, they're like stretched and long and
Wait,
funky.
how do you know which points to plug in?
You just have to plug in numbers on this side of the line and numbers on that side of the line.
So it doesn't have to be.
No, but you might, but I try to space them out on these ones, because these graphs look so weird, you want to space them out so that you get a bigger picture, does that make sense? Okay, so over here, let's plug in 4, and after we do this, I promise you're done. 4, 4, 4, right? 4 squared, 16 plus 12 minus 4, right? 16 plus 12 minus 4 is 24, and then you're dividing it by -2, right? Is that what was on the bottom? No, you're just dividing it by 6, I like that name. What am I doing? It's not plus 2, it's minus 2, so you're dividing it by 2, so 12, yes? 4 should be 12. And then we're gonna plug in 8, so 8 squared 64. I know this takes forever, I'm sorry. 8 squared is 64, 3 times 8 is 24, 64 plus 24 minus 4 is 84. And then 8 minus 2 is 6, so 84 divided by 6 is 14. And then we're plugging in 12, 12 squared is 144, yes?
Yes,
Now do you see why why I count by twos, they're such big numbers?
yeah.
Okay, so 144 and 3 times 12 is 36 plus 144 minus 4 is 176, and it's divided by 10, which gives me,
17.6.
so, 2, 4, 6, 8, 10, 12, 17.6, 2, 4, 6, 8, 10, 12, 14, 16, so someplace in between here. 8, 2, 4, 6, 8, 14, 2, 4, 6, 8, 10, 12, 14. And then 4, 12, 4, 2, 4, 6, 8, 10, 12. Okay, this one still looks kind of funky because,
They're all together?
yeah, because it's not on graph paper too, but it's going to go like this. It's going to face, it should actually, if I plug in something less than 4, like 3 or 1, it's gonna go like this. It's gonna mirror what that one's doing down there. So like one's going this way and one's coming this way. They just look weird because I don't have graph paper on the board, okay? So those things are you're doing. Here's the deal, remember on the graphs, if you input